Deep in the archives of ancient texts, scattered across continents and millennia, preserved in languages both living and dead, lies evidence of a celestial phenomenon that has captivated humanity for 2,000 years. These documents, some written on papyrus scrolls that crumbled at a touch, others inscribed on clay tablets that survived the rise and fall of empires, others still recorded in the meticulous bamboo records of imperial China, all speak in their own ways about what we see in the night sky and what those sights might mean. In the cold desert nights of the ancient Near East, when darkness fell complete and absolute in ways our light-polluted modern world can scarcely imagine, when the Milky Way blazed overhead like a river of light, and every star stood out sharp and clear, wise men from distant lands looked upward. These were not simple shepherds or casual observers. These were learned scholars, men who had spent lifetimes studying the movements of celestial bodies, who could predict eclipses and calculate planetary positions, who understood the complex symbolic language through which the heavens were believed to speak to those who knew how to listen. They saw something in the heavens that compelled them to undertake a journey of hundreds of miles through desert wastes and across mountains, leaving behind their homes and their comfortable lives. They sought a newborn king, guided by what has become the most famous astronomical object in human history. More ink has been spilled, more theories proposed, more investigations launched into this single celestial phenomenon than perhaps any other in the annals of astronomy. It has inspired some of the greatest scientific minds across centuries, from the dawn of modern astronomy to our present age of supercomputers and space telescopes. Yet for all its fame, for all the paintings and songs and stories it has inspired, for all the scientific papers and popular books, for all the planetarium shows and documentaries, we still don't know exactly what the Star of Bethlehem was. This simple fact is both humbling and fascinating. In an age when we can detect planets orbiting distant stars, when we can measure the composition of gases in the atmospheres of worlds light years away, when we can look back in time to within a fraction of a second after the Big Bang, we cannot definitively identify a star that appeared in our own sky just 2 millennia ago. The mystery begins simply enough. In the Gospel of Matthew chapter 2, we read of Magi from the east who came to Jerusalem asking, "Where is he who has been born King of the Jews? For we saw his star when it rose and have come to worship him." These mysterious visitors, often called the 3 wise men in later tradition, though the biblical text never actually specifies their number, travelled to King Herod's palace. Herod, troubled by news of a prophesied rival, consulted his own advisers. They pointed to ancient prophecies that spoke of Bethlehem as the birthplace of the Messiah. Secretly intending to find and eliminate this potential threat to his throne, Herod directed the Magi to search for the child in Bethlehem and report back to him. The text tells us that when the Magi had received this direction, they departed. And then something remarkable happened. The star they had seen in the east went before them until it came to rest over the place where the child was. When they saw the star, they rejoiced exceedingly with great joy. They entered the house, saw the child with Mary his mother, and fell down to worship him. Opening their treasures, they offered gifts of gold, frankincense, and myrrh. Warned in a dream not to return to Herod, they departed to their own country by another way. That's the account as recorded in Matthew's Gospel. It's a story that has echoed through the centuries, inspiring countless works of art, music, and literature. Every Christmas, millions of people around the world place a star atop their trees or display nativity scenes with a bright star shining above a humble stable. The image is so familiar that we sometimes forget to ask the obvious question, what actually was this star? For a story so central to Christian tradition, the biblical account is remarkably sparse in astronomical details. We're not told exactly when the star appeared, though it seems to have been visible for some time before the Magi reached Jerusalem. We're not told its colour, its brightness relative to other stars, or its position in the sky beyond being in the east. The phrase in the east itself is somewhat ambiguous in the original Greek and could mean several things. It might mean the star rose in the eastern sky, or it could be a technical astronomical term referring to a morning star, a planet visible before sunrise. The account tells us the star went before the Magi and stood over the place where the child was. This description has puzzled readers for millennia. How can a star in the distant heavens appear to hover over a specific building? Stars are unimaginably far away. Even the nearest star beyond our Sun, Proxima Centauri, is over 4 light-years distant. No ordinary star could point to a specific house in Bethlehem, any more than the North Star can point to a specific tree in a forest. This apparent impossibility has led many to dismiss the account as purely symbolic or mythological. Others have suggested it must have been a miraculous sign, entirely outside the realm of natural explanation. But there's a third possibility, one that has fascinated astronomers for centuries. Perhaps the Star of Bethlehem was a real astronomical phenomenon, something unusual enough to capture the attention of ancient stargazers, something that could plausibly explain the details in Matthew's account when understood through the lens of ancient astronomy and astrology. The search for a natural explanation of the Star of Bethlehem is not an attempt to explain away the miraculous. Rather, it's an exploration of how the divine might work through the natural order, how a creator who set the stars in motion might orchestrate their movements to mark moments of cosmic significance. It's a question that sits at the intersection of faith and science, of ancient wisdom and modern knowledge, of history and astronomy. To understand what the star might have been, we need to understand when it appeared. This seemingly simple question opens up a labyrinth of historical complications. The traditional dating of Jesus' birth to year 0, or more precisely to the year 1 AD, since there is no year 0 in our calendar, is almost certainly incorrect. We know from both biblical and historical sources that Jesus was born during the reign of Herod the Great. The ancient Jewish historian Josephus, writing near the end of the 1st century, provides detailed information about Herod's life and death. According to Josephus, Herod died shortly after a lunar eclipse, and his death was followed by Passover. Modern astronomical calculations allow us to identify which lunar eclipse this was, and the most widely accepted date for Herod's death is 4 BC. This means Jesus must have been born before 4 BC, but how much before? Matthew's account tells us that Herod, after learning from the Magi about the star, ordered the massacre of all male children in Bethlehem 2 years old and under, according to the time he had ascertained from the wise men. This suggests the star appeared as much as 2 years before Herod's death, potentially placing the birth of Jesus and the appearance of the star somewhere between 7 and 5 BC. This time window is crucial because it allows us to search ancient astronomical records for unusual celestial events. And here we encounter a fascinating fact. The ancient world, particularly in China and Babylon, maintained remarkably detailed records of astronomical observations. These meticulous sky watchers noted eclipses, planetary positions, comets, and unusual stellar phenomena. Their observations, preserved in clay tablets and bamboo scrolls, have survived to our time and can be read and analysed by modern astronomers. The Chinese, in particular, kept extraordinarily comprehensive astronomical records stretching back millennia. They had official court astronomers whose job was to observe and record any unusual phenomena in the heavens. These weren't casual hobbyists. These were trained professionals working in a bureaucratic system that valued precision and completeness. They recorded comets, noting their appearance, movement, and duration. They noted new stars, what they called guest stars, which we now understand to have been novas and supernovas. They tracked the positions of planets with impressive accuracy. What makes these Chinese records so valuable is that they were kept for astrological and calendrical purposes, not religious ones. The Chinese had no knowledge of or interest in events in far-off Judea. Their astronomical observations were made independently of any biblical narrative. This makes them invaluable as objective evidence for what was actually visible in the sky during the years around the traditional time of Jesus' birth. When we examine these records for the period between 7 and 5 BC, we find something intriguing. Chinese astronomers noted unusual celestial phenomena during precisely this time frame. The question is, can any of these phenomena explain the Star of Bethlehem as described in Matthew's Gospel? Before we can answer that question, we need to understand what ancient peoples meant when they spoke of stars. In the ancient world, the word we translate as star encompassed more than just the fixed points of light we call stars today. Planets, which appeared as bright moving lights in the sky, were also called stars. The Greek word used in Matthew's Gospel, aster, could refer to any luminous celestial body. This broadens considerably the range of phenomena that might account for the Star of Bethlehem. We also need to understand ancient astrology. To modern ears, astrology often sounds like pseudoscience or superstition, but in the ancient world there was no clear distinction between astronomy, the observation and recording of celestial phenomena, and astrology, the interpretation of these phenomena as signs or omens. The same people who carefully tracked the positions of planets also interpreted those positions as having meaning for earthly events. The Magi, or wise men, who came seeking Jesus were almost certainly astrologers. The Greek word magoi refers to a class of learned men, probably from Persia or Babylon, who were skilled in interpreting dreams, reading omens, and particularly in understanding the movements of celestial bodies. These weren't primitive superstitious people. They were highly educated scholars working within sophisticated intellectual traditions that had been developed over centuries. In the ancient Near East, astrology was taken very seriously by rulers and common people alike. The movements of planets, the appearance of comets, eclipses, and conjunctions of celestial bodies were all carefully noted and interpreted. Different cultures had different systems of interpretation, but all shared the fundamental belief that the heavens and the earth were connected, that what happened above had meaning for what happened below. This is crucial for understanding the Star of Bethlehem. We need to think not just about what would have been visually spectacular to a modern observer, but what would have been astrologically significant to ancient astrologers. The Star of Bethlehem didn't need to be the brightest object in the sky. It didn't need to be visible to everyone. It needed to be something that trained astrologers, versed in the symbolic language of the heavens, would recognize as signifying the birth of a great king, specifically a king of the Jews. With this background in mind, let's begin our journey through the major theories that have been proposed to explain the Star of Bethlehem. Our guide for much of this journey will be a man who lived 16 centuries after the birth of Christ, but whose work revolutionized our understanding of the heavens and set the stage for all subsequent investigations into the Christmas star. On the evening of October 17th, 1604, the skies over Prague finally cleared after days of clouds and rain. The German astronomer Johannes Kepler had been impatiently waiting for this opportunity. He had been tracking the movements of planets with his usual meticulous attention, and he knew that something interesting was happening in the heavens. Jupiter and Saturn, two of the most prominent planets visible to the naked eye, were drawing close together in the sky. Mars, the red planet, was nearby as well. This conjunction, as astronomers call it when celestial bodies appear to pass close to each other, was astrologically significant by the standards of Kepler's time. But what Kepler saw that October evening exceeded all his expectations. There, in the constellation of Ophiuchus, near where the three planets were congregating, blazed a new star. It appeared suddenly where no star had been before, shining brilliantly enough to be visible in broad daylight. Over the following weeks it grew even brighter, becoming one of the most luminous objects in the night sky before gradually fading over the course of about a year. Kepler was not the first person to spot this new star. Others had seen it a few days earlier. But Kepler's observation was different because of who he was and what he did next. Kepler was one of the greatest scientific minds of his age, a mathematician who would soon discover the fundamental laws of planetary motion. He was also a deeply religious man who saw no conflict between his scientific work and his Christian faith. As he observed this brilliant new star appearing in conjunction with Jupiter, Saturn, and Mars, his mind made a connection that would influence astronomical thinking about the Star of Bethlehem for centuries to come. What Kepler had witnessed was a supernova, though that term wouldn't be coined for another 3 centuries. We now understand supernovas as the explosive death of certain types of stars, events so energetic they can briefly outshine entire galaxies. The supernova Kepler observed in 1604, now known as Kepler's supernova, or Sen 1604, was the last supernova in our Milky Way galaxy to be visible to the naked eye. Its remnant can still be detected by modern telescopes, an expanding shell of gas and energy marking the site of that long-ago explosion. But in 1604, Kepler had no conception of what a supernova really was. What struck him most forcefully was the timing. Here was a brilliant new star appearing in the sky in close association with a conjunction of major planets. And Kepler, who was both an astronomer and an astrologer, for in his time the two disciplines were still intertwined, knew that such conjunctions were considered astrologically significant. His mind raced backward through time. Jupiter and Saturn were then, as now, the 2 largest planets visible to ancient observers. When they drew close together in the sky, it was a relatively rare event, occurring only once every 20 years. But there was something even more special about the conjunction Kepler had just observed. Because of the elliptical paths of planetary orbits, sometimes a conjunction of Jupiter and Saturn doesn't happen just once, but 3 times in close succession as the planets appear to pass each other, then reverse direction due to the effects of Earth's own motion, pass again, reverse once more, and pass a 3rd time. This is called a triple conjunction, and it's much rarer than a simple conjunction. Kepler immediately set to work calculating when such triple conjunctions had occurred in the past. This was no easy task. Kepler lived before the age of computers, before even mechanical calculators. Everything had to be worked out by hand, using the mathematical tables and methods available in the early 17th century. But Kepler was a mathematical genius, perhaps the finest computational astronomer of his age. His calculations revealed something fascinating. A triple conjunction of Jupiter and Saturn had occurred in the year 7 BC. This would have been right around the time that Jesus was born, given that Herod the Great died in 4 BC and Jesus must have been born before Herod's death. Could this conjunction, Kepler wondered, have been the Star of Bethlehem that the Magi followed? Kepler initially thought that perhaps the conjunction itself had somehow triggered the appearance of a nova, a new star like the one he had just observed. He was wrong about this. We now know that planetary conjunctions don't cause novae or supernovae. But his insight about the 7 BC conjunction was revolutionary. He had discovered a real astronomical event that occurred at approximately the right time, and that would have been astrologically significant to ancient observers. Let me explain exactly what happened in 7 BC, because it's a beautiful piece of celestial mechanics. Jupiter, with its orbital period of about 12 years, and Saturn, with its orbital period of about 29 years, periodically overtake each other from Earth perspective. When they do, they appear to draw close together in our sky. In 7 BC, these 2 giants of the solar system began their dance in the constellation of Pisces. The first conjunction occurred in May of that year. An observer looking to the western sky after sunset would have seen Jupiter and Saturn drawing closer and closer together until they appeared to almost touch, though in reality they were separated by hundreds of millions of miles, just appearing close due to the alignment of their orbits as seen from Earth. Then something interesting happened. Due to the phenomenon called retrograde motion, which occurs because we're observing these planets from Earth, which is also in motion, the planets appeared to reverse direction in the sky. Jupiter seemed to move backward relative to the background stars. This brought the 2 planets back toward each other, and in September they met again for their second conjunction of the year. After this second meeting, the planets resumed their normal forward motion, only to slow once more and meet a 3rd time in December. 3 times in 7 months, the 2 brightest planets known to ancient astronomy came together in the sky. This wasn't just rare, this was extraordinary. A triple conjunction of Jupiter and Saturn happens only about once every 139 years. But there's more. The constellation in which this occurred, Pisces, held special significance in ancient astrology. While there's some scholarly debate about this, many ancient sources associated Pisces with the region of Judea. Jupiter was universally recognized as the king planet, associated with rulers and royalty. Saturn was also linked to the Jewish people by some ancient sources. The appearance of these 2 planets meeting 3 times in Pisces could plausibly have been interpreted by learned astrologers as signifying the birth of a great king in Judea. Did the Magi see this triple conjunction? Did they interpret it as signalling the birth of the Jewish Messiah? The timing works. If the conjunction began in May of 7 BC and the Magi immediately set out on their journey, which would have taken several weeks or even months from Babylon or Persia to Jerusalem, they could easily have arrived in Bethlehem by late 7 BC or early 6 BC, well within the window of time before Herod's death in 4 BC. Kepler published his findings in 1606 in a treatise with the wonderfully Baroque title, De Stella Nova in Pede Serpentari, or On the New Star in the Foot of the Serpent Bearer. This book would prove enormously influential. For the next 4 centuries, the 7 BC triple conjunction of Jupiter and Saturn would be one of the leading candidates for the Star of Bethlehem. Planetariums around the world would recreate it in their shows every Christmas season. Books and articles would cite it as the most likely explanation for what the Magi saw. But as compelling as this theory might seem, it faces significant problems. Modern calculations, which are far more precise than anything available to Kepler, show that even at their closest approach, Jupiter and Saturn were separated by nearly a degree of arc in the sky. That's about twice the width of the full moon. To the naked eye, they would have appeared as 2 distinct points of light that came close but never merged. This would have been interesting to ancient astrologers certainly, but not visually spectacular. More problematically, conjunctions of planets are relatively common events. Any given pair of bright planets comes into conjunction somewhere in the sky every few years. Even triple conjunctions, while rare, occur periodically. If the Magi had been waiting for centuries for a sign of the Messiah's birth, would a planetary conjunction, no matter how rare, have been sufficient? Wouldn't they have seen other conjunctions throughout their lifetimes, or known of others from historical records? And there's a more fundamental issue. The biblical text says the star went before the Magi and stood over the place where the child was. Planets don't do this. They rise in the east and set in the west, following the same daily motion as the sun and stars due to Earth's rotation. They don't hover over specific locations on the ground. From any given location, you can't follow a planet to a specific building. If you tried to follow Jupiter to Bethlehem from Jerusalem, you'd end up walking in circles as the planet rose, arced across the sky, and set, only to repeat the cycle the next night. Despite these difficulties, the conjunction theory has remained popular, and for good reason. It identifies a real astronomical event that occurred at approximately the right time, and that would have been astrologically meaningful to ancient observers. Kepler's work demonstrated that we could use modern astronomical knowledge to recreate the ancient sky and search for phenomena that might explain the Star of Bethlehem. But Kepler's contribution went beyond just identifying the 7 BC conjunction. His work on planetary motion revolutionized astronomy. Before Kepler, astronomers assumed that planets moved in perfect circles, as ancient Greek philosophy had taught. This assumption created endless complications because planets don't actually move in circles. Their orbits are ellipses, a fact that Kepler discovered through years of painstaking analysis of observations made by his mentor, the Danish astronomer Tycho Brahe. Kepler's 3 laws of planetary motion, published between 1609 and 1619, provided the first accurate mathematical description of how planets actually move. These laws would later be explained by Isaac Newton's theory of gravity, but Kepler discovered them empirically, simply by analysing the data until he found patterns that fit the observations. This work made it possible for astronomers to calculate the positions of planets in the past or future with unprecedented accuracy. This capability has proven crucial for investigating the Star of Bethlehem. Using Kepler's laws and modern computational power, astronomers can recreate the exact configuration of the night sky, as it would have appeared from any location on Earth at any time in history. We can see precisely where every planet was on any given night 2,000 years ago. We can identify conjunctions, eclipses, and other astronomical events with perfect accuracy. This means we're no longer limited to searching ancient records for mentions of unusual celestial phenomena. We can actively calculate what was in the sky during the years around Jesus' birth, and look for events that might have caught the attention of ancient astrologers. This has led to a proliferation of theories about the Star of Bethlehem, each backed by precise astronomical calculations. One of the most intriguing developments in this search came much later, building on Kepler's work but taking it in new directions. In the late 20th century, astronomer Michael Molnar made a discovery that would revolutionise thinking about the Star of Bethlehem. But before we get to Molnar's theory, we need to explore other possibilities that have been proposed over the years. If the 7 BC triple conjunction of Jupiter and Saturn faces problems as an explanation for the Star of Bethlehem, what about other planetary conjunctions? The night sky is constantly in motion. The planets are always moving against the background of stars, sometimes approaching each other, sometimes spreading apart. Might some other conjunction better fit the biblical account? One of the most spectacular planetary events that can occur is a conjunction of Jupiter and Venus. Venus is the brightest natural object in the sky after the Sun and Moon. Jupiter, while not as bright as Venus, is still extremely luminous, typically the second or third brightest point of light in the night sky, after Venus and occasionally Mars. When these two brilliant planets come close together, the result can be truly striking. In December of 2020, the world witnessed a close conjunction of Jupiter and Saturn that was called a Great Conjunction, and dubbed by some as a Christmas star. The two planets came so close together that to the casual observer they appeared almost as a single bright point of light. This event captured public imagination and led many to ask whether a similar conjunction might have been the original Star of Bethlehem. Astronomer Roger Sinnott, writing in the journal Sky and Telescope, identified a remarkable conjunction of Jupiter and Venus that occurred in 2 BC. On June 17th of that year, these two planets came so close together in the constellation Leo that they would have appeared to merge into a single brilliant object. This would have been a genuinely spectacular sight, far more impressive visually than the 7 BC Jupiter-Saturn triple conjunction. The June 2nd BC Venus-Jupiter conjunction has several things going for it as a candidate for the Star of Bethlehem. First, it would have been extremely bright, far brighter than any star in the sky. Second, it occurred in Leo, the constellation of the Lion, which was associated with royalty and kingship. Third, Venus and Jupiter are both traditionally associated with divine or royal significance in astrological systems. Attorney Frederick Larson, who has written extensively about the Star of Bethlehem, favours this 2 BC conjunction as part of a longer sequence of celestial events. His theory, which he has presented in lectures and a documentary video, suggests that the Magi followed a series of astronomical signs stretching over several years. According to Larson's reconstruction, the sequence began in 3 BC with a series of 3 conjunctions between Jupiter and the star Regulus, often called the King Star, as it's the brightest star in Leo. These conjunctions would have gotten the attention of astrologers versed in celestial symbolism. Jupiter, the king planet, meeting 3 times with Regulus, the king star, in Leo, the sign of royalty. This could hardly have been more clear as an announcement of a royal birth. 9 months later, approximately the human gestation period, Jupiter and Venus came together in their spectacular conjunction of June the 2nd BC. This, Larson suggests, would have signalled to the Magi that the prophesied king had now been born. They immediately set out on their journey from Babylon to Jerusalem. Jupiter continued to move through its orbit, and by December of 2nd BC, it reached a point in its motion called a stationary point. This is when a planet appears to stop its movement across the sky before reversing direction, a result of the changing angles as we observe it from Earth, which is also moving. Larson notes that December 25th, the date Christians later chose to celebrate Christmas, was precisely when Jupiter appeared to stop in the sky, and this stationary point occurred when Jupiter would have been in the southern sky as viewed from Jerusalem, the direction of Bethlehem. Could this explain the biblical statement that the star went before them and stood over where the child was? Larson argues yes. He suggests that when the Magi left Jerusalem for Bethlehem, they would have travelled in the early morning hours, and Jupiter would have been visible in the southern sky, appearing to lead them toward Bethlehem. When Jupiter reached its stationary point, it would have appeared to stop, hovering in roughly the same position night after night. This is an elegant theory that accounts for several aspects of the biblical narrative. However, it faces significant chronological problems. If Jesus was born in 2 BC, this would be after the traditionally accepted date for Herod's death in 4 BC. How could Herod have ordered the massacre of infants if he was already dead? Some scholars have challenged the 4 BC date for Herod's death, arguing that it could have been as late as 1 BC based on reinterpretation of the historical evidence. Early Christian historians Eusebius and Clement of Alexandria calculated Jesus' birth to around 3 or 2 BC, but this remains a minority view. Most historians accept that Herod died in 4 BC based on the converging evidence from multiple ancient sources. There's another issue with all planetary conjunction theories, including Larson's. The direction argument doesn't really hold up under scrutiny. Jerusalem is less than 10 miles from Bethlehem. The two locations are so close that any object in the sky would appear in virtually the same position from both places. You can't navigate between two nearby towns by following a star or planet any more than you can navigate by following the sun. Celestial objects are so distant that parallax, the slight shift in position due to viewing from different locations, is negligible over such short distances. Astronomer David Weintraub, author of a book on the Star of Bethlehem, puts it bluntly, "You can't follow a star from Baghdad to Jerusalem to Bethlehem. Stars don't do that. They rise and set, and they don't sit in the sky." But perhaps we're being too literal in interpreting the biblical text. Maybe the star went before them doesn't mean they physically navigated by following it across the landscape, but rather that the celestial sign they had been observing continued to be visible, confirming they were on the right path. And maybe stood over where the child was doesn't mean it hovered like a helicopter directly above a specific building, but rather that it was positioned in the sky in a way that seemed to mark the general area of Bethlehem. If we're willing to interpret the text less literally, then planetary conjunctions become more plausible candidates. The 2 BC Venus-Jupiter conjunction certainly would have been spectacular enough to be called a star. Early Christian sources sometimes describe the Star of Bethlehem as extremely bright enough to dim the light of the sun, which is obviously an exaggeration, but might reflect the exceptional brilliance of Venus and Jupiter appearing together. Yet another planetary conjunction has been proposed as the Star of Bethlehem, one that involves more than just two planets. Astronomer Michael Molnar, whose full theory we'll explore in detail later, has noted that in addition to Jupiter and Venus conjunctions, there were also significant alignments involving other planets and the Moon in the years around Jesus' birth. The Moon, as it orbits Earth, regularly passes in front of planets, temporarily blocking them from view. This is called an occultation. While occultations of planets by the Moon are common events, occurring many times each year, ancient astrologers regarded them as significant, especially when they involved major planets like Jupiter. Molnar identified two occultations of Jupiter by the Moon that occurred in Aries in 6 BC on March 20th and April 17th. These events would not have been visually spectacular. They occurred near the Sun in the sky and would have been difficult or impossible to see with the naked eye. But they would have been astrologically significant, particularly because Jupiter was in Aries at the time. Why does Aries matter? This gets to the heart of Molnar's revolutionary insight, and it's something we'll explore in depth later. For now, let's just note that ancient astrological texts associate different zodiac signs with different regions and peoples. Molnar's research into ancient astrology suggests that Aries, not Pisces as many had assumed, was the sign associated with Judea in the time of Jesus' birth. An occultation of Jupiter, the king planet in Aries, the sign of Judea, could have been interpreted as signalling the birth of a king of the Jews. There's another planetary theory worth mentioning, though it's less widely accepted than the conjunctions we've discussed. Some researchers have noted the possibility of a rare close approach of 3 or even 4 planets simultaneously. In February of 6th BC, Jupiter, Saturn and Mars came into relatively close alignment in Pisces. While not as close as the June 2nd BC Venus-Jupiter conjunction, this 3-planet grouping would have been striking and unusual. Ancient astrologers paid close attention to groupings of multiple planets, seeing in them complex layers of meaning based on the symbolic associations of each planet and the constellation in which they appeared. A meeting of 3 major planets in a significant constellation could have been interpreted as an especially powerful omen. All these planetary theories share certain strengths and weaknesses. On the positive side, they identify real astronomical events that can be dated precisely. We don't have to speculate about whether something appeared in the sky. We know exactly where every planet was on every night 2,000 years ago. These conjunctions and occultations really happened. Moreover, these events would have been astrologically meaningful to ancient observers. The movements of planets were closely watched and interpreted according to elaborate systems of symbolic meaning. A conjunction of major planets in a significant constellation would certainly have attracted attention from learned astrologers. On the negative side, planetary conjunctions and occultations are relatively common. While some conjunctions are rarer than others, ancient astrologers would have seen many such events over their lifetimes. Why would one particular conjunction have been interpreted as signalling the birth of the Messiah when others before it were not? And there's still the problem of the biblical description that the star stood over where the child was. No matter how we try to reinterpret this phrase, it's hard to make it fit with a planetary conjunction. Planets simply don't behave the way the text seems to describe. Perhaps then, we need to look beyond planets to other types of celestial phenomena. What if the Star of Bethlehem wasn't a planet or conjunction at all, but something more dramatic and unexpected? What if it was a star that truly was new, a light that appeared suddenly where none had been before? When Johannes Kepler observed his brilliant new star in 1604, he was witnessing one of the most powerful events in the universe, the explosive death of a star. We now call such events supernovas, though Kepler had no way of knowing what he was really seeing. To him and his contemporaries, it was simply a nova, a new star, an object that appeared suddenly in the heavens where none had existed before. The appearance of a nova challenged ancient Greek astronomy, which held that the heavens were perfect and unchanging. According to Aristotle and other Greek philosophers, the celestial realm beyond the moon was made of a perfect, incorruptible substance called ether. Change, generation and decay occurred only in the sublunary sphere, the realm of earth and air beneath the moon's orbit. Stars were fixed, eternal, unchangeable. But occasionally new stars did appear. Ancient Chinese and Korean astronomers recorded several such events. The most famous is the supernova of 1054 AD, which was visible in the daytime sky for weeks and remained visible at night for nearly 2 years. The expanding cloud of gas from this explosion is now called the Crab Nebula, one of the most studied objects in the sky. Could the Star of Bethlehem have been a supernova or nova? The possibility is tantalizing. A supernova would certainly qualify as unusual and spectacular enough to send ancient astrologers on a long journey. Some supernovas are bright enough to be visible in daylight. They appear suddenly, blaze brilliantly for weeks or months, and then gradually fade, the entire event lasting perhaps a year or two before the star disappears from view. This behaviour fits certain aspects of the biblical account. The star apparently appeared at a specific time, which is exactly what a supernova does. The Magi saw it in the east, suggesting it had recently become visible. It was visible long enough for them to make a journey of several weeks or months from their homeland to Jerusalem. And it may have faded after they found Jesus, as they don't mention seeing it again after leaving Bethlehem. The nova theory has had many supporters over the years. After Kepler witnessed his supernova in 1604, he initially thought that perhaps a similar event had occurred around the time of Jesus' birth. Other astronomers have since searched historical records for evidence of a nova or supernova around 7 to 5 BC. The most promising evidence comes, once again, from Chinese astronomical records. These meticulous observers recorded the appearance of a guest star that appeared in the year we call 5 BC and remained visible for over 70 days. Chinese records describe it as appearing out of Altair, which we understand to mean near the star Altair in the constellation Aquila. The description uses the term huixing, which can mean either a comet or a tailed star. Could this have been the Star of Bethlehem? The timing is certainly right. If the star appeared in March or April of 5th BC, as the Chinese records suggest, it would have been visible during the time frame when Jesus could plausibly have been born. Bethlehem scholar Colin has argued that this Chinese record provides strong evidence that the Star of Bethlehem was a nova, or possibly a comet, though interpreting these ancient records is complicated by the limited detail they provide and differences in ancient classification systems. Korean astronomers also recorded what may have been the same object, or possibly a different one. Their records mention a star in 4 BC. If these Korean and Chinese observations refer to the same celestial event, it suggests the object was visible for an extended period, which would be consistent with a bright nova. But there are significant problems with the nova theory. First, and most obviously, Western astronomical records from around this time make no mention of any nova. The Romans, Greeks, and Babylonians were all actively observing the skies, yet none of their records that survive today mention a bright new star appearing in 5 or 4 BC. Why would Chinese and Korean astronomers have noticed it, but not observers in the Mediterranean region? One possibility is that the nova was positioned in such a way that it was more easily visible from East Asia than from the Middle East. The time of year when it was above the horizon might have been different, or perhaps Western records simply haven't survived. The Romans, despite their sophisticated civilization, kept relatively few systematic astronomical records compared to the Chinese. A moderately bright nova might have been noted in the east but overlooked in the west. There's a more fundamental problem, though. If the nova was the Star of Bethlehem, and it was bright enough to be recorded by Chinese astronomers thousands of miles away, shouldn't it have been visible to everyone in the Middle East? The biblical account suggests that the Magi saw the star and understood its significance, but others, including King Herod, did not. Herod had to ask the Magi when the star appeared. He wasn't already aware of it. This suggests the celestial phenomenon wasn't obviously visible to everyone. This issue actually affects all theories of a bright, obvious celestial object being the Star of Bethlehem. Astronomer David Weintraub makes this point effectively. If the bright star didn't guide them, it only told them when to set out. In other words, the star was a sign that astrologers interpreted, not a phenomenon that every person would have recognized as significant. A nova, or supernova, being an unexpected and dramatic change in the heavens, would certainly have been noticed by many people. Yet the Gospel account suggests the star was not common knowledge. King Herod, who had advisors and surely kept some astronomical watch, was unaware of it until the Magi told him. This suggests the star was either not very bright or it was bright, but its astrological significance was understood only by specialists. Modern astronomy has added another complication to the supernova theory. We now understand that supernovas leave behind remnants, expanding shells of gas that continue to glow for thousands of years. These remnants can be detected by modern telescopes. Kepler's supernova of 1604, though it's no longer visible to the naked eye, can still be observed with X-ray telescopes as an expanding bubble of hot gas and energy. If the Star of Bethlehem was a supernova in our galaxy, we should be able to find its remnant. Astronomers have searched for such a remnant in the region where the Chinese records suggest their guest star appeared. So far, no convincing remnant has been found dating to this time period. This doesn't absolutely rule out a supernova. Remnants can be faint and difficult to detect, but it does make the theory less likely. Some researchers have proposed more exotic variations of the nova theory. Physicist Frank Tipler suggested that the Star of Bethlehem might have been a supernova in the Andromeda Galaxy, our nearest large galactic neighbour. A supernova in another galaxy would be too distant to leave a detectable remnant solving that problem. And while galactic supernovas are rare, occurring perhaps once per century in a given galaxy, they do occur, so one might plausibly have happened in Andromeda around the right time. However, a supernova in Andromeda would not be nearly as bright as a supernova in our own galaxy. The Andromeda Galaxy is about 2.5 million light-years away, roughly 100,000 times more distant than typical stars in our galaxy. A supernova in Andromeda might be visible, but it would appear as a relatively faint new star, not a dramatic blazing object. Would such a faint supernova have attracted the attention of ancient astronomers? Possibly, if they were carefully mapping the positions of stars and noticed a new faint point of light that hadn't been there before. But this brings us back to the same issue. If it was faint enough that only careful observers would notice it, it fits even less well with the dramatic description in later Christian tradition of a brilliant star lighting the way to Bethlehem. There's one final issue with nova and supernova theories that applies to all of them equally. Novas and supernovas appear at a fixed position in the sky. They don't move relative to the background stars. They simply appear, brighten, remain in the same spot for weeks or months, and then fade away. This means they can't really be said to go before anyone or stand over anywhere. They rise and set each night with all the other stars due to Earth's rotation, but they don't move across the sky from night to night the way planets do. How then could the star have gone before the Magi and stood over Bethlehem? The only way to make this fit is to interpret the text very loosely, suggesting perhaps that the star was visible in a particular direction from their starting point, and remained visible throughout their journey, confirming they were on the right path. But this requires considerable reinterpretation of what seems like fairly straightforward language in the Gospel. Despite these difficulties, the nova theory persists, because it has one enormous advantage over planetary theories. A nova truly is a star, or at least something that ancient people would have called a star without hesitation. It appears suddenly, it's unusual and remarkable, and its appearance at a specific time could plausibly be interpreted as marking a significant event. If we can find evidence of a nova at the right time in the right part of the sky, it would be hard to dismiss as a candidate for the Star of Bethlehem. But there's another type of celestial phenomenon that has many of the advantages of a nova while avoiding some of its problems. Throughout history, these objects have been seen as omens and portents, appearing unexpectedly in the sky, and putting on spectacular displays before vanishing back into the depths of space. They're bright, they move across the sky, and ancient people definitely called them stars. In the cold pre-dawn hours of March, 5 BC, somewhere in the ancient Near East, perhaps in the courts of Babylon or the plateaus of Persia, an astrologer looked up from his nightly observations and saw something that made him catch his breath. There, low in the eastern sky, just becoming visible before the approaching sunrise, was a fuzzy, elongated object that definitely hadn't been there the night before. Over the following nights it grew brighter and clearer, a distinct head with a glowing tail stretching upward toward the zenith. The astrologer carefully noted its position, its appearance, and its movement. This was a comet, a rare and significant celestial visitor. Thousands of miles away, in the palaces of the Han Dynasty in China, official court astronomers made similar observations. They recorded in their meticulous records that in the second month of the second year of the rain period Qianping, a Hui Xing, a tailed star, appeared in the region of Qianyu, which we identify with the constellation Capricorn. They noted that it remained visible for more than 70 days. Could this comet, recorded independently by observers across Asia, have been the Star of Bethlehem? The comet theory has a long and distinguished history, and unlike some other theories, we have actual ancient records of a celestial object appearing at approximately the right time. Comets are among the most spectacular objects visible in the night sky. Unlike planets, which appear as steady points of light, or stars, which are so distant they appear as dimensionless dots even in the largest telescopes, comets are extended objects. They have a bright head, or nucleus, surrounded by a glowing cloud called a coma, and often a tail stretching across the sky, sometimes spanning 30 degrees or more, the width of 60 full moons. The tail of a comet is one of its most distinctive features. It's created by solar radiation and the solar wind pushing gas and dust away from the comet's nucleus as it approaches the sun. The remarkable thing about comet tails is that they always point away from the sun, regardless of the comet's direction of motion. This means a comet's appearance changes dramatically depending on where it is in its orbit and where we are relative to it. When a comet is approaching the sun from the outer solar system, its tail stretches behind it like the wake of a ship. When it rounds the sun and heads back out, it leads with its tail like a spear or an arrow. When it passes near Earth, the geometry of Sun, Comet and Earth can create situations where the comet's tail appears to point directly up or down in our sky, like a pillar of light rising from or descending to the horizon. This last point is crucial. Throughout history, when observers saw comets with tails pointing upward or downward, they described them as hanging over specific locations. Chinese records are full of such descriptions, comets hanging over this city or that province. This is, of course, an illusion. The comet is millions of miles away in space, but from Earth's surface, the geometry of the comet's position and the direction of its tail can create the compelling visual impression that it's pointing at a specific location. Ancient people considered comets to be powerful omens. In the classical Mediterranean world, comets were generally seen as bad signs, portents of war, plague, or the death of kings. The appearance of a bright comet in 44 BC, shortly after the assassination of Julius Caesar, was interpreted as the soul of Caesar ascending to join the gods. The Bayeux Tapestry, depicting the Norman conquest of England in 1066, shows a comet in the sky, probably Halley's Comet, which appeared that year and was seen as an omen of the coming invasion. But not all cultures interpreted comets negatively. Chinese astronomical texts describe comets as omens that could be either auspicious or inauspicious, depending on their characteristics and the circumstances of their appearance. A comet appearing at the right time in the right part of the sky might signal the birth of a great ruler or a change of dynasty. For the Star of Bethlehem to have been a comet, we need several things to be true. First, a bright comet must have appeared around the time of Jesus' birth. Second, it must have been visible from the Middle East. Third, its appearance and behaviour should roughly fit the description in Matthew's Gospel. And ideally, we should find independent confirmation of this comet in ancient records. The Chinese record of a Hui Xing in 5 BC checks several of these boxes. The timing is right within the window when Jesus could have been born before Herod's death in 4 BC. The object was apparently visible for over 70 days, long enough for observers to track it carefully and for travellers to make a journey of many weeks. But there are complications. The Chinese term hui xing literally means broom star, referring to a star with a tail, like a broom. While this term was often used for comets, it was sometimes also applied to novas or other unusual celestial phenomena. Some scholars who have analysed this particular record have noted oddities about it. Unlike most comet records, which describe the object's movement across the sky, this record gives a fixed position over 2.5 months. If it was truly a comet, wouldn't it have moved? One possible explanation is that the record is simply incomplete or has been garbled in transmission. Ancient texts were copied and recopied by hand over centuries. Details could be lost or altered. The core information that something unusual appeared in the sky and remained visible for over 70 days might be accurate, even if other details are unclear. Astronomer Colin Humphreys, who has written extensively about the Star of Bethlehem, suggests that the Chinese record, combined with a Korean record of a similar object in 4 BC, points to a bright comet that was visible for an extended period around 5 to 4 BC. He argues that this comet is the best candidate for the Star of Bethlehem. There's another comet that sometimes enters the discussion, Halley's Comet. This famous comet, which returns to the inner solar system every 75 to 76 years, was visible in 12 BC. Some early researchers suggested this might have been the Star of Bethlehem. However, 12 BC is too early, several years before the generally accepted window for Jesus' birth. Even if we allow for uncertainty in ancient dating, 12 BC is pushing the limits of credibility, given that Jesus had to be born before Herod's death in 4 BC. More recently, New Testament scholar Colin Nicholl has developed an elaborate and detailed theory that the Star of Bethlehem was a great comet, though not one for which we have definite historical records. Nicholl's theory, presented in his book The Great Christ Comet, published in 2015, represents one of the most comprehensive attempts to explain the Star of Bethlehem from an astronomical perspective. Nicholl starts by carefully analysing the biblical text, noting several key points. The star appeared at a specific time and was visible for an extended period. It was significant enough to cause learned astrologers to undertake a long journey. It appeared to move in the sky in a way that could be described as going before the travellers, and finally, it seemed to stand over or point to a specific location. No ordinary star could do all these things. A planetary conjunction fits some of these requirements, but not others. A nova fits some, but not all. But a comet, Nicholl argues, could potentially fit all of them. A bright comet appears suddenly. It remains visible for weeks or months. It moves across the sky from night to night as it orbits the Sun, and crucially, depending on the geometry of its orbit and our viewing angle, its tail can appear to point directly at a location on the horizon. Nicholl proposes that a long-period comet, the type that takes thousands of years to complete one orbit around the Sun, and might never have been seen before by human observers, appeared in the sky in 6 BC. This comet, according to his reconstruction, would have first become visible as it approached the inner solar system, passing Earth on its way toward the Sun. As it approached the Sun, it would have brightened dramatically, possibly becoming bright enough to see in daylight. The geometry of its orbit, Nicholl suggests, would have taken it through the constellation Virgo. Nicholl connects this to the vision in Revelation chapter 12 of a woman clothed with the sun, with the moon under her feet and a crown of 12 stars on her head, giving birth to a child. He interprets this vision as a description of actual astronomical phenomena that the author of Revelation saw and understood as relating to the birth of Jesus. According to Nicholl's scenario, the comet's appearance in Virgo in late summer of 6 BC would have been interpreted by astrologers as announcing a virgin birth. The comet would then have continued its journey, rounding the Sun and heading back toward the outer solar system. As it did so, its orbital path would have taken it through other constellations, each passage potentially adding layers of meaning to the astrological interpretation. The comet would have faded as it moved away from the Sun, but it would have remained visible for months, perhaps over a year. during this time the Magi would have been observing it, interpreting its significance, preparing for their journey, and finally setting out for Judea. By the time they approached Bethlehem, the comet would have been positioned in the sky such that its tail appeared to point downward toward the southern horizon, the direction of Bethlehem as viewed from Jerusalem. Nicholl's theory is elaborately detailed and takes into account many factors other theories overlook. He considers the viewing geometry, the brightness of the comet at different points in its orbit, the astrological symbolism of the constellations it passed through, and the timeline of events described in Matthew's Gospel. His book includes dozens of astronomical diagrams and careful analyses of ancient astrological texts. The theory is impressive in its scope and attention to detail, but it faces one major problem. We have no definite historical record of such a spectacular comet in 6 BC. The Chinese records mention the possible comet or nova in 5 BC, which doesn't quite fit Nicholl's timeline. No other contemporary sources mention a great comet in 6 BC. Nicholl addresses this objection by noting that ancient astronomical records are incomplete. The Chinese records we have are compilations and summaries made centuries after the fact. The original daily observational records kept by Han Dynasty astronomers haven't survived. We have only selected excerpts, compiled into books of historical summaries. A comet that appeared at the wrong time of year, when monsoons or other factors limited visibility in China, might have been observed but not recorded in the surviving summaries. Western records from this period are even sparser. The Romans didn't keep systematic astronomical records comparable to the Chinese. Greek astronomical texts from this period are largely lost. Babylonian astronomical diaries, which are remarkably detailed, have significant gaps. The absence of a record of a comet doesn't prove it didn't exist, only that we don't have documentation of it in the surviving sources. This is a reasonable point, but it does make Nicholl's theory unfalsifiable in a scientific sense. He's proposing a comet for which we have no direct evidence other than the biblical text he's trying to explain. The comet exists in his theory because it needs to exist to explain the Star of Bethlehem, but we can't independently verify its existence. Despite this limitation, Nicholl's work represents a serious attempt to grapple with all the details of the biblical account and explain them through a natural astronomical phenomenon. Whether or not his specific scenario is correct, his work demonstrates that a comet could, in principle, explain many aspects of the Star of Bethlehem story that other theories struggle with. The comet theory has one more advantage worth mentioning. Comets were definitely regarded as significant by ancient peoples. They weren't everyday occurrences. A bright comet might appear once in a generation or less. When one did appear, it captured attention and was interpreted as meaningful. This fits the biblical account better than very common phenomena like ordinary planetary conjunctions. But there's a countervailing disadvantage. In classical Mediterranean culture, comets were generally seen as bad omens, signs of disaster, war, or death. Would the Magi, travelling to worship a newborn king, have been guided by an object that their contemporaries would have interpreted as a sign of doom? Perhaps they were working within a different interpretive framework, one that saw comets as neutral or even positive signs depending on the circumstances. Or perhaps the very nature of what they saw, a particular type of comet with distinctive characteristics, was understood differently from typical comets. One fascinating detail that Nicholl explores in his book is the possibility that the comet was associated with a meteor storm. When Earth passes through the debris trail left behind by a comet, we can see meteor showers, or rarely meteor storms, where hundreds or thousands of meteors streak across the sky in a short period. If the comet that appeared around the time of Jesus' birth left behind a debris trail, and if Earth happened to pass through this trail, observers might have witnessed a spectacular meteor display that could have been interpreted as stars falling from heaven, a phenomenon with its own prophetic and apocalyptic associations. This is speculative, but it shows how much complexity can be hidden in what seems like a simple question. What was the Star of Bethlehem? Each layer we peel back reveals new possibilities and new complications. We've now explored three major categories of theories: planetary conjunctions, novas or supernovas, and comets. Each has its strengths and weaknesses. Each can claim to explain some aspects of the biblical account while struggling with others. Is there any way to definitively choose between them? Before we try to answer that question, we need to consider one more approach, one that differs fundamentally from all the theories we've discussed so far. Instead of asking what modern astronomical phenomenon could explain the Star of Bethlehem, what if we asked a different question? What would ancient astrologers have been looking for? What astronomical signs would they have interpreted as announcing the birth of a great king of the Jews? In the early 1990s, Michael Molnar, an astronomer at Rutgers University, was browsing through an antique coin shop when something caught his eye. It was a Roman coin from Antioch, dated to the early 1st century AD, about the same period as the events described in the Gospels. On one side of the coin was a portrait of the Roman emperor, but it was the reverse side that intrigued Molnar. It showed a ram, the zodiacal sign of Aries, looking back over its shoulder at a star. Molnar was a coin collector as well as an astronomer, but he'd never seen a coin quite like this one before. The combination of the ram and the star seemed oddly specific. Why would someone mint a coin with this particular image? As he researched the coin's symbolism, Molnar began to realize he might have stumbled onto something significant. For years, astronomers searching for the Star of Bethlehem had been looking for spectacular visual phenomena, things that would be bright and obvious in the night sky. They assumed that whatever the Star of Bethlehem was, it must have been something anyone could see and recognize as unusual. But Molnar's background in the history of astronomy led him to question this assumption. The Magi, or wise men, who came seeking Jesus, were described in Matthew's Gospel using the Greek word magoi. This term had a specific meaning in the ancient world. It referred to members of the priestly caste of ancient Persia and Media, learned men who specialized in several fields including astronomy, astrology, and the interpretation of dreams and omens. These weren't casual stargazers. They were highly trained specialists working within sophisticated intellectual traditions that had been developed over centuries. The ancient Babylonians and Persians had developed complex systems of astrology that bore little resemblance to the simplified horoscopes in modern newspapers. Their astrology was a serious scholarly discipline that involved careful observation of celestial phenomena and interpretation according to elaborate rules and traditions. Different celestial events meant different things depending on when they occurred, what constellation they occurred in, the phase of the moon, the positions of other planets, and many other factors. Molnar realized that modern astronomers searching for the Star of Bethlehem had been looking for what we today would find visually impressive. But what mattered wasn't what we would notice, it was what ancient astrologers would have considered astrologically significant. And these might be very different things. An event that's visually spectacular, like a close conjunction of two planets appearing as one brilliant object, might not be especially meaningful in ancient astrological systems. Conversely, an event that's barely visible or even invisible to the naked eye might be immensely significant astrologically. What mattered wasn't how bright something was, but what it meant according to the complex symbolic language of ancient astrology. This insight was revolutionary, and it led Molnar to study ancient astrological texts in detail, something few modern astronomers had bothered to do. What he found was illuminating and surprising. Ancient astrology was far more sophisticated than he'd imagined, and it operated according to principles quite different from what modern people might guess. One of Molnar's key discoveries concerned the zodiac sign associated with Judea. For years, researchers had assumed that Pisces was the sign connected with Judea and the Jewish people. This assumption was based on medieval sources. But when Molnar examined ancient sources from the time of Jesus, particularly the Tetrabiblos of Claudius Ptolemy, written in the 2nd century AD but drawing on earlier traditions, he found something different. According to Ptolemy and other ancient sources, Aries, not Pisces, was the zodiacal sign governing Judea. This might seem like a minor technical point, but it completely changes which astronomical events would have been seen as significant for Judea. Astrologers looking for signs about events in Judea would have been watching Aries, not Pisces. Armed with this knowledge, Molnar began to search ancient records for significant astrological events in Aries around the time of Jesus' birth. What he found would form the basis of his theory of the Star of Bethlehem, published in his 1999 book The Star of Bethlehem, The Legacy of the Magi. Molnar identified two occultations of Jupiter by the moon that occurred in Aries in 6 BC. An occultation, as we mentioned earlier, is when the moon passes in front of another celestial body, temporarily blocking it from view. On March 20th and April 17th of 6th BC, the moon passed in front of Jupiter, while Jupiter was in the constellation Aries. Now, occultations of planets by the moon are actually quite common. They happen many times each year as the moon moves along its orbital path. But in ancient astrology, certain occultations were considered highly significant. The key factors were which planet was occulted, which zodiac sign it was in, and the positions of other celestial bodies at the time. Jupiter was universally recognized in the ancient world as the king planet, associated with rulers and sovereignty. An event involving Jupiter had royal significance. Jupiter in Aries, the sign of Judea, meant the event concerned Judea specifically. And an occultation, where the moon passed in front of Jupiter, was a particularly powerful form of conjunction in ancient astrological thinking. Molnar found evidence in ancient astrological texts that this exact configuration, a lunar occultation of Jupiter in Aries, was understood to signify the birth of an important ruler. The Roman astrologer Firmicus Maternus, writing in the 4th century AD but drawing on earlier Greek sources, explicitly states that an occultation of Jupiter in Aries portended the birth of a divine king. But here's where Molnar's theory gets really interesting. The occultations he identified occurred when Jupiter was what astronomers call a morning star. This doesn't mean Jupiter looked like a star. Planets and stars look quite different to trained observers. It means Jupiter was visible in the eastern sky before sunrise, rising ahead of the sun. In ancient astrological terminology, a planet in the east referred specifically to this morning star phenomenon. When Matthew's Gospel says the Magi saw his star in the east, Molnar argues this is a technical astrological term meaning they saw Jupiter as a morning star. The phrase doesn't mean they saw it while they were in the east, or that it was located in the eastern part of the sky, but that Jupiter was rising heliacally, emerging from the sun's glare to become visible as a morning star. On April 17th, 6th BC, Jupiter was precisely in this configuration. It was a morning star rising in the east before the sun. It was in Aries, the sign of Judea. And on that very day the moon occulted Jupiter. According to ancient astrological principles, Molnar argues, this configuration would have been interpreted by learned astrologers as announcing the birth of a divine king in Judea. Now comes an important point. These occultations would not have been visually spectacular. Jupiter was close to the sun in the sky at the time. The occultations probably weren't even visible to the naked eye, or if they were, they would have been difficult to observe in the brightness of dawn. But here's the crucial insight. Ancient astrologers didn't necessarily need to observe these events directly. They calculated them. The Babylonians and their intellectual heirs had developed sophisticated mathematical techniques for predicting the positions of the moon and planets. They could calculate when occultations would occur without necessarily observing them. In fact, many important astrological events in their systems occurred during the day or otherwise couldn't be observed, but they were calculated and considered meaningful nonetheless. This explains several puzzling aspects of the Star of Bethlehem story. It explains why King Herod didn't know about the star even though he had advisors and access to information. The star wasn't obvious. It wasn't a bright new object in the sky that anyone could see. It was an astrologically significant configuration that had to be calculated and interpreted. Only specialists in astrology, like the Magi, would have known about it and understood its meaning. It also explains the phrase, "We have seen his star in the east." Molnar suggests this doesn't mean they literally saw it with their eyes, though they may have. The Greek word used can mean to perceive, or to understand as well as to physically see. They perceived, through calculation and astrological interpretation, that the celestial configuration indicated the birth of the King of the Jews. Molnar's theory was initially met with some skepticism from other scholars, but it has gained considerable support over the years. Harvard astronomer Owen Gingerich, one of the leading historians of astronomy, has endorsed Molnar's approach, calling his book the most original and important contribution of the entire 20th century to understanding the Star of Bethlehem. At a 2014 colloquium on the Star of Bethlehem held in the Netherlands to mark the 400th anniversary of Kepler's work, Molnar's theory was debated and gained significant support, though not universal acceptance. The genius of Molnar's approach is that it doesn't require searching for a spectacular astronomical event that somehow wasn't recorded by anyone other than Matthew. Instead, it identifies a configuration that, while not visually dramatic, would have been astrologically significant to ancient specialists. It takes seriously the fact that the Magi were astrologers, not just people who happened to look up and see something bright. But Molnar's theory faces challenges too. Not all scholars accept his conclusion that Aries, rather than Pisces, was the sign associated with Judea in the 1st century BC. The ancient sources are not entirely consistent on this point. Some later sources do associate Pisces with the Jews, though Molnar argues these are medieval interpretations that don't reflect earlier practice. There's also the question of the biblical description that the star went before them and stood over where the child was. Molnar addresses this by suggesting the reference is to another aspect of Jupiter's behaviour. In December of 6 BC, Jupiter reached a stationary point in its apparent motion across the sky. This is when a planet appears to stop moving and reverse direction, a result of the changing angles as Earth and the planet orbit the Sun. At this stationary point, Jupiter would have appeared in the southern sky from Jerusalem, roughly in the direction of Bethlehem. Molnar suggests that when the Magi left Jerusalem to go to Bethlehem, which is less than 10 miles away, Jupiter would have been visible in the direction they were travelling, appearing to go before them. And at its stationary point it would appear to stand still rather than moving across the sky from night to night as it usually does. This is plausible, though it requires interpreting the biblical text in a fairly specific way. It also raises the question of whether Jupiter at a stationary point would really appear to hang over a specific location. Planets at stationary points still rise, and set each night due to Earth's rotation. They don't hover over one spot on the ground. Despite these questions, Molnar's work has fundamentally changed how scholars think about the Star of Bethlehem. He demonstrated that we need to understand ancient astrology on its own terms, not just look for what we would find impressive. His approach has inspired other researchers to dig deeper into ancient astrological texts, and to think more carefully about how ancient peoples interpreted celestial phenomena. Interestingly, 2 researchers at University College London, Mark Kidger and Colin Humphreys, independently discovered that there were actually 2 pairs of occultations in early 6 BC. On March 19th, the day before the first Jupiter occultation, the Moon also occulted Saturn. And on April 16th, the day before the second Jupiter occultation, the Moon again occulted Saturn. This creates an even more complex and potentially more significant astrological picture. Saturn was associated in ancient astrology with the Jews and with the Sabbath. Having both Jupiter and Saturn occulted by the Moon in successive days, happening twice, would have created an extraordinarily rare and complex configuration. Molnar argues that this adds weight to his theory, suggesting that the astrological significance of this period in early 6 BC would have been impossible for ancient astrologers to miss. One of the most striking things about Molnar's theory is that it came not from an astronomer searching the skies for impressive phenomena, but from a close reading of ancient coins and texts. The ancient coin that started his investigation, showing Aries looking back at a star, may have been minted specifically to commemorate this astrological event. Antioch, where the coin was made, was a major centre of early Christianity. The coin may represent early Christian awareness that Jesus' birth was marked by significant celestial signs. Molnar's work reminds us that ancient peoples saw the world very differently from how we see it. They operated with different categories, different systems of meaning. What mattered to them wasn't necessarily what would matter to us. To truly understand what the Star of Bethlehem might have been, we need to enter into their world view, to see the heavens as they saw them, interpreted through their symbolic systems. This doesn't mean we can ever know with certainty what the Star of Bethlehem was. The evidence is fragmentary, the ancient records incomplete, the biblical text itself remarkably brief. But Molnar's work, like Kepler's before him, and Nicholl's contemporary with him, shows that serious, rigorous investigation can yield new insights, even into mysteries 2,000 years old. In the centuries since Johannes Kepler first turned his mathematical genius to the question of the Star of Bethlehem, our ability to understand and recreate ancient skies has improved dramatically. Modern astronomers have tools at their disposal that Kepler could never have imagined. Powerful computers can calculate planetary positions with exquisite precision, recreating the exact configuration of the sky as it would have appeared from any location on Earth at any time in history. Planetarium software like Stellarium, Starry Night and others allows anyone with a computer to become a time traveller of sorts. You can set the location to Jerusalem or Babylon, wind the clock back to 7 BC or 5 BC or any year you choose, and see exactly what the sky looked like on any given night. You can watch as planets move through their stately dance across the zodiac. You can see conjunctions occurring and note their exact dates. You can identify which stars were visible, calculate the positions of the moon, and reconstruct celestial events with accuracy that would have astounded ancient astronomers. This capability has proven invaluable for investigating the Star of Bethlehem. Researchers can test various theories by recreating ancient skies and checking whether the astronomical events they propose actually occurred as described. We're no longer dependent solely on ancient records or hand calculations. We can see for ourselves what was in the sky. For example, when Michael Molnar proposed that Jupiter was occulted by the Moon in Aries on April 17th, 6 BC, other researchers could immediately check his claim using planetarium software. Sure enough, the occultation occurred exactly as he described. The position of Jupiter, the timing of the occultation, the other planets in the sky at the time, all these can be verified independently. Similarly, researchers investigating Colin Nicholl's comet theory can use orbital mechanics software to test whether a comet with the orbital parameters he proposes would have appeared in the sky the way he describes. They can calculate what such a comet would have looked like from different locations at different times, how bright it would have been, what direction its tail would have pointed. This ability to recreate and verify astronomical events has both clarified and complicated the search for the Star of Bethlehem. On one hand, we can now definitively rule out certain theories. If someone proposes that a particular conjunction occurred on a specific date, we can check immediately whether that's accurate. Claims that don't hold up to astronomical scrutiny can be dismissed. On the other hand, the precision of modern astronomy has revealed just how many interesting events occurred in the years around Jesus' birth. The sky's always doing something. Planets are always moving, coming into various configurations with each other. The moon regularly occults planets and stars. Once we know what to look for and have the tools to search systematically, we find an almost embarrassing abundance of potentially significant astronomical events. In the years between 7 and 5 BC, multiple interesting things happened. There was the 7 BC triple conjunction of Jupiter and Saturn that Kepler identified. There was the possible nova or comet in 5 BC that Chinese astronomers recorded. There were the Jupiter occultations in 6 BC that Molnar identified. There were various other planetary alignments and conjunctions. Depending on what you think would have been astrologically significant, you can find events to fit almost any theory. This has led some scholars to suggest that perhaps we're asking the wrong question. Instead of looking for a single astronomical event that was the Star of Bethlehem, perhaps we should be looking for a sequence of events. Maybe the Magi observed a series of celestial phenomena over an extended period, and this sequence convinced them that something momentous was happening. This is essentially what Frederick Larson argues in his Jupiter-Venus conjunction theory. He proposes that the Magi observed a series of events stretching from 3 BC to 2 BC, conjunctions of Jupiter with Regulus, then Jupiter with Venus, then Jupiter at its stationary point. The sequence of events created an astrological narrative that pointed to the birth of a king in Judea. Similarly, some versions of the conjunction theory suggest that the 7 BC triple conjunction of Jupiter and Saturn was just the beginning. This was followed by planetary groupings in 6 BC, and possibly the comet or nova in 5 BC. The cumulative effect of these events over several years would have been increasingly convincing to astrologers looking for signs of the Messiah's birth. Modern computer simulations have also revealed interesting subtleties about how celestial events appear from Earth. For example, when planets come into conjunction, the visual effect depends not just on how close they appear, but also on atmospheric conditions, the time of night, and the observer's visual acuity. Two planets separated by a degree might appear nearly merged to one observer under good conditions, but clearly separate to another observer, or under different viewing conditions. Similarly, the visibility of comets depends on many factors. A comet might be intrinsically quite bright but difficult to see if it's too close to the sun in the sky, or if it appears low on the horizon where atmospheric haze dims it. Computer models can calculate a comet's brightness, but translating that into how visible it would have been to ancient observers requires assumptions about weather, atmospheric conditions, and the observer's experience and eyesight. Modern astronomy has also helped us understand the limitations of ancient records. The Chinese astronomical records are remarkably detailed and accurate, but they're not complete. The records we have are compilations made centuries after the fact, drawing on original observations that no longer survive. Astronomical phenomena that occurred during periods of bad weather might not have been recorded. Events deemed unimportant at the time might have been omitted from later compilations. Western records are even sparser. The Romans kept relatively few systematic astronomical records. What records they did keep often don't survive. This means we shouldn't expect every significant astronomical event to be documented in multiple independent sources. The absence of a record doesn't prove something didn't occur. Modern astronomy can tell us what was physically possible. If someone proposes that a nova appeared in a particular constellation at a particular time, and we find evidence for a supernova remnant of the right age in that part of the sky, that supports the theory. If we search for such a remnant and find none, that doesn't absolutely disprove the theory, but it makes it less likely. Computer simulations can show us what ancient peoples could have seen, but they can't tell us what those people would have considered significant. This is where astronomy needs to be supplemented by historical research into ancient astrology, cultural beliefs, and religious expectations. The most sophisticated astronomical calculation can tell us exactly where Jupiter was on April 17th, 6th BC, but it takes historical research into ancient astrology to know whether anyone would have cared. This interdisciplinary approach, combining astronomy, history, archaeology, linguistics, and religious studies, represents the cutting edge of current research into the Star of Bethlehem. No single discipline can solve the mystery. We need astronomers to tell us what was in the sky, historians to tell us how ancient peoples thought, linguists to help us understand ancient texts, archaeologists to uncover contemporary material evidence. One fascinating recent development has been the use of ancient astronomical texts to verify modern calculations. Babylonian astronomical diaries, written on clay tablets in cuneiform script, provide detailed observations of planetary positions and lunar phases, going back centuries before Jesus' birth. These records allow us to check our computer calculations of planetary positions against actual ancient observations. The remarkable thing is that they match almost perfectly. Our computer models of planetary motion are so accurate that they can predict where Mars was in the sky on a specific night in 234 BC to within a tiny fraction of a degree. This gives us great confidence that we're correctly reconstructing ancient skies. When we say Jupiter and Saturn came into conjunction in May of 7 BC, we're not guessing. We can calculate their positions with the same precision we use to navigate spacecraft through the solar system today. But all this astronomical precision still can't answer the fundamental question: which of the many interesting astronomical events around the time of Jesus' birth was the one that the Magi interpreted as signalling the birth of the King of the Jews, or was it none of them? Was the Star of Bethlehem something else entirely, something that doesn't fit neatly into our astronomical categories? We've journeyed through 2,000 years of speculation, investigation, and debate. We've examined planetary conjunctions, supernovas, comets, and astrological configurations. We've learned about ancient astrology, Chinese astronomical records, and modern computer simulations. We've met some of the brilliant minds who have tackled this mystery, from Johannes Kepler to Michael Molnar to Colin Nicholl. And yet, despite all this effort, despite centuries of investigation by some of the finest scientific minds, we still don't know with certainty what the Star of Bethlehem was. We have theories, some more compelling than others. We have possibilities, each with its strengths and weaknesses, but we don't have proof. The mystery endures. Why is this? Why can't we solve a question about something that happened in the sky, something that in principle is subject to precise mathematical calculation? Part of the answer is that the biblical account itself is remarkably brief. Matthew gives us only a few verses about the star. He doesn't tell us what it looked like, exactly when it appeared, how long it was visible, or precisely where in the sky it was located. The details we'd need to definitively identify the phenomenon are simply not in the text. This brevity might seem frustrating to modern readers who want to solve the mystery, but perhaps it's intentional. The Gospel was written not as an astronomical treatise, but as a theological narrative. What mattered to the author was not the scientific details of the star, but its significance. It was a sign that God was doing something new, that ancient prophecies were being fulfilled, that the hope of the nations was being born in a humble town in Judea. There's another reason the mystery endures. The further back in time we go, the fewer and more fragmentary our sources become. We have some ancient astronomical records, particularly from China, but these records don't cover every night or every part of the sky. They note unusual events deemed worthy of recording, but they're selective. An event that seemed minor at the time might not have been recorded, even if we today might find it significant. And we're trying to understand people who thought very differently from us. Ancient astrology was a complex symbolic system we only partially understand. We can read ancient astrological texts, but fully reconstructing how ancient peoples interpreted celestial events requires getting inside their worldview in ways that may not be fully possible across such vast gulfs of time and culture. There's also the question of whether we should even be looking for a natural explanation. Many Christians have historically believed that the Star of Bethlehem was a miraculous sign, entirely outside the normal order of nature. If that's the case, no amount of astronomical investigation will find it because it wasn't an astronomical phenomenon in the ordinary sense. But even those who believe in the possibility of miracles can appreciate the investigation into natural explanations. If God chose to announce the birth of Jesus through some dramatic arrangement of natural celestial phenomena, that in itself is remarkable. The author of Psalm 19 wrote, "The heavens declare the glory of God, and the sky above proclaims his handiwork." If the Star of Bethlehem was a planet, a comet, or a supernova, orchestrated by the same power that set the stars in motion to appear at precisely the right time, to be interpreted as announcing the Messiah's birth. That's no less wondrous than a purely supernatural sign. Indeed, there's something profound about the idea that God works through natural means. The laws of physics, the orbits of planets, the life cycles of stars, all these follow predictable mathematical patterns. Yet from these deterministic patterns can emerge what appears to be meaningful coincidence. A planet reaches just the right position, in just the right constellation, at just the right moment in history. Is that chance? Or is it design working through natural law? This question takes us beyond astronomy into philosophy and theology, and perhaps that's appropriate. The Star of Bethlehem is not merely an astronomical puzzle, it's a question that sits at the intersection of science, history and faith. Different people will approach it from different perspectives and with different assumptions. What can we say with confidence? We can say that multiple interesting astronomical events occurred around the time of Jesus' birth. The 7 BC triple conjunction of Jupiter and Saturn really happened. The 6 BC occultations of Jupiter in Aries really happened. Something was recorded in Chinese astronomical records in 5 BC, though exactly what remains debated. There were other planetary configurations and celestial events during this period. We can say that ancient peoples, particularly in the Near East, paid close attention to celestial phenomena and interpreted them according to sophisticated astrological systems. The idea that learned men might travel a great distance because of something they observed or calculated in the sky is entirely plausible in the context of ancient culture. We can say that the Gospel account, while brief, is consistent with various astronomical explanations. Whether it's a planetary conjunction, a comet, or an astrological configuration, each theory can account for at least some aspects of the biblical description, though none accounts for all aspects perfectly. What we cannot say with certainty is which, if any, of these events was the one the Magi interpreted as the Star of Bethlehem. The evidence is simply insufficient to make a definitive determination. We can have theories, some more plausible than others. We can have preferences based on how well different theories fit the evidence. But we cannot have certainty. Some might find this frustrating. We live in an age of scientific certainty, where we can measure the mass of distant galaxies and detect gravitational waves from colliding black holes. Surely we should be able to identify a star that appeared 2,000 years ago, but perhaps there's value in mystery. Perhaps there's something important about questions that remain open, phenomena that resist simple categorization, stories that invite wonder rather than merely explaining away. The search for the Star of Bethlehem has driven centuries of astronomical investigation. It inspired Kepler's work on planetary motion. It has motivated careful study of ancient texts and records. It has brought together scholars from different fields, astronomy and history, science and theology. This interdisciplinary conversation has enriched our understanding of ancient world, the history of astronomy, and how different ways of knowing the world can complement each other. And regardless of what the Star of Bethlehem was astronomically, its meaning remains powerful. It represents the idea that the birth of every human being, but especially one who would change the world, is cosmically significant. It suggests that the heavens and the earth are connected, that there's a correspondence between the vast celestial realm and our small human lives. It speaks to the longing that many peoples throughout history have felt, that the stars might have something to tell us, that we're not alone in the universe. In our time, we've lost much of the intimate connection ancient peoples felt with the night sky. Light pollution obscures the stars from view in most populated areas. We navigate by GPS rather than constellations. We know the planets are dead worlds of rock and gas, not divine wanderers carrying portents for earthly events. Yet something in us still responds to the mystery of the Star of Bethlehem. We still put stars atop our Christmas trees. We still gaze up on clear winter nights and feel the same sense of wonder ancient peoples felt. The stars, for all our scientific understanding of them, remain awesome in the original sense of that word. They inspire awe. Perhaps that's the real gift of the Star of Bethlehem mystery. It reminds us that the universe is larger and stranger than we can fully comprehend. It invites us to look up, to wonder, to seek, even when we know we may never find complete answers. It suggests that some of the most important truths can't be fully captured in equations or reduced to simple explanations. The search for the Star of Bethlehem continues. New researchers bring new tools and new perspectives. Ancient texts yet unstudied might yield new clues. Future archaeological discoveries might provide new evidence. Or perhaps someday a comet will return to the inner solar system, following the same orbit one may have followed 2,000 years ago, and we'll recognise it as the Christmas star completing its long journey through the outer darkness. Until then, we're left with the story as Matthew tells it. Wise men from the east saw a star. They understood it as a sign. They journeyed to find a newborn king. They offered gifts and worshipped, and then they went home by another way, changed by what they had found. Perhaps the message isn't ultimately about identifying which astronomical phenomenon was the star. Perhaps it's about being willing to look up, to recognise signs, to journey toward truth even when the path is long and uncertain. Perhaps it's about the transforming power of seeking and finding. Perhaps it's about going home by another way, changed by the journey. The Star of Bethlehem shocked astronomers not just because it was unusual or bright, but because it represents something that resists easy categorization. It's simultaneously a natural phenomenon and a meaningful sign, a subject for scientific investigation and religious contemplation, a historical event and a timeless symbol. As we conclude our journey through this mystery, we're left not with certainty but with wonder, and perhaps that's exactly where we're meant to be. The heavens still declare, the stars still shine, and mysteries still invite us to look up and seek. If you've enjoyed this exploration of the Christmas star, please consider liking this video and subscribing to our channel. We explore the wonders of science in depth, bringing you long-form content that delves into the mysteries of our universe. From ancient astronomical puzzles to cutting-edge physics, we're here to feed your curiosity and help you discover the remarkable stories written in the fabric of reality. Join our community of curious minds and let's continue exploring together. Clear skies and may you never stop wondering. To truly understand what the Magi might have seen and why it mattered to them, we need to step back and consider who these people actually were. The term Magi comes from the Greek magoi, which itself derives from the Old Persian magush. In the ancient world, this referred to members of a priestly caste associated with the Medes and Persians. Learned men who specialised in several interconnected fields of knowledge that we today would separate into distinct disciplines: astronomy, astrology, dream interpretation, medicine, and philosophy. The Magi were not primitive superstitious people consulting tea leaves and reading palms. They were highly educated scholars working within sophisticated intellectual traditions that stretched back centuries. They studied in institutions that resembled universities, learning from texts and teachers, mastering complex mathematical and observational techniques. They maintained libraries and observatories. They trained for years or even decades to master their craft. The astronomical knowledge of ancient Mesopotamia, the cultural region from which the Magi likely came, was extraordinarily advanced. The Babylonians had been systematically observing and recording celestial phenomena for over 1,000 years before the time of Jesus' birth. They had identified the planets and tracked their movements. They had discovered the Saros cycle, an 18-year pattern of eclipses that allowed them to predict when eclipses would occur. They had developed mathematical models to calculate planetary positions. These observations were recorded on clay tablets in cuneiform script, thousands of which have survived to our time. Modern scholars have translated many of these tablets, and what they reveal is astonishing. The Babylonian astronomers achieved remarkable precision in their observations and calculations, often coming within tiny fractions of a degree in their predictions of where planets would be on given dates. Why did they go to such lengths to study the sky? Partly for practical reasons. Accurate calendars were essential for agriculture, for religious festivals, for governance. Predicting eclipses was politically important, as these events were often interpreted as omens. But there was also a deeper motivation. The Babylonians, and later the Persians, Greeks and others who inherited their astronomical traditions, believed that the heavens and the earth were intimately connected, that what happened above had meaning for what happened below. This wasn't a simplistic one-to-one correspondence. It was a complex symbolic system in which celestial events were interpreted according to elaborate rules that took into account multiple factors: which planets or stars were involved, which constellations they appeared in, the phase of the moon, the season, and many other variables. Different schools of astrological interpretation had different methods, and debates raged among practitioners about proper technique. Let's consider the practical realities of the Magi's journey. Matthew's Gospel tells us they came from the east, but from how far east? The most likely origin point is Babylon, in what is now Iraq, which was a major centre of astronomical learning. The distance from Babylon to Jerusalem is approximately 900 miles as the crow flies, though the actual travelled distance would have been considerably longer due to the need to follow routes with reliable water sources and to avoid impassable terrain. In the ancient world, travelling such distances was no trivial undertaking. Camel caravans might cover 20 to 30 miles per day under good conditions, meaning the journey would have taken a minimum of 6 to 8 weeks, and more likely 2 to 3 months when accounting for rest days, delays, and the slower pace necessary when travelling through difficult terrain. The Magi would not have travelled alone. A small group of important men carrying valuable gifts across hundreds of miles of sometimes hostile territory would have needed protection. They likely travelled with a larger caravan, perhaps dozens of people including guards, servants, animal handlers, and guides. Such a caravan would have been expensive to organise and maintain, requiring significant financial resources. What would have motivated such an expedition? The Magi weren't travelling out of idle curiosity. They were making a long, difficult, expensive, and potentially dangerous journey because they believed something of cosmic importance had occurred or was about to occur. Whatever celestial phenomenon they observed or calculated, it must have been extraordinarily significant within their interpretive framework to justify such an undertaking. Consider also the risks. Travelling from Babylon to Jerusalem meant crossing multiple political boundaries. The region was not always stable. Bandits plagued trade routes. Desert crossings were perilous. The Magi were strangers in foreign lands, and strangers, especially those claiming to seek a newborn king, might not always be welcomed, yet they went. This speaks to the power of what they had seen or calculated in the heavens. In their worldview, the celestial sign was so clear, so unmistakable in its meaning, that it overcame all practical objections and propelled them on this remarkable journey. One of the challenges in investigating the Star of Bethlehem is the complex question of ancient chronology. When exactly was Jesus born? This seemingly simple question opens up a maze of historical and calendrical complications. Our modern calendar, the Gregorian calendar, introduced by Pope Gregory III in 1582, is designed to keep the date of Easter relatively stable relative to the spring equinox. It's based on an earlier calendar, the Julian calendar introduced by Julius Caesar in 45 BC. Both of these calendars use a system of year numbering supposedly based on the birth of Jesus, with years marked as BC, before Christ, or AD, Anno Domini, Year of the Lord. However, this year numbering system was not introduced until centuries after Jesus' death. It was developed in 525 AD by a monk named Dionysius Exiguus, who was trying to calculate the date of Easter. Dionysius's calculations were based on fragmentary historical records and involved some guesswork. Most modern historians believe he got it wrong, placing Jesus' birth too late by several years. The key evidence comes from the Gospel of Matthew, which tells us Jesus was born during the reign of Herod the Great, and from the Jewish historian Josephus, who provides detailed information about Herod's life and death. Josephus tells us Herod died shortly after a lunar eclipse and before a Passover. By identifying which lunar eclipses were visible from Jerusalem and correlating them with Passover dates, historians have determined that Herod most likely died in 4 BC, with some scholars arguing for 1 BC based on different interpretations of the evidence. This means Jesus must have been born before 4 BC. But how much before? Matthew's account implies the Magi arrived sometime after Jesus' birth, possibly up to 2 years after, based on Herod's subsequent order to kill all male children 2 years old and under. This suggests Jesus could have been born anywhere from about 7 BC to 5 BC, though some scholars push the dates earlier or later based on different readings of the evidence. The ancient world used multiple different calendar systems. The Jews used a lunar calendar based on the phases of the moon. The Romans used the Julian calendar. The Persians and Babylonians had their own systems. Chinese records use year-reign dating. Correlating dates between these different systems is complex and sometimes uncertain. This chronological uncertainty affects our search for the Star of Bethlehem. An astronomical event that occurred in 7 BC might fit if we place Jesus' birth early in the possible time window. An event in 5 BC or even 4 BC might fit if we place it later. Different theories about what the star was often depend on different assumptions about exactly when Jesus was born. To properly evaluate whether a comet could have been the Star of Bethlehem, we need to understand what comets are and how they behave. Modern astronomy has revealed that comets are, in essence, dirty snowballs, mixtures of ice, rock, and frozen gases that orbit the Sun in highly elliptical paths. For most of their orbit, comets are inert, frozen objects drifting through the cold outer reaches of the solar system. But when a comet's orbit brings it close to the Sun, something dramatic happens. The Sun's heat causes the ice to sublimate, turning directly from solid to gas. This gas, along with dust particles embedded in the ice, streams away from the comet, pushed by solar radiation and the solar wind. This creates the comet's characteristic tail, which can stretch for millions of miles across space. Actually, most comets have 2 tails. The dust tail, made of small particles released as the ice sublimes, is pushed away from the Sun by the pressure of sunlight. It curves backward along the comet's orbit, creating a sweeping arc. The ion tail, made of electrically charged gas molecules, is pushed straight back from the Sun by the solar wind. It appears as a straight beam of bluish light. From Earth, the appearance of a comet depends on its distance from both the Sun and Earth, the size and composition of its nucleus, and the angle at which we view it. A comet far from the Sun might appear as a faint fuzzy patch, barely distinguishable from a distant nebula. As it approaches the Sun and brightens, it develops a distinct head, the coma, a glowing cloud of gas and dust surrounding the nucleus. Then the tail appears, growing longer and brighter as the comet draws nearer to the Sun. The brightest comets, sometimes called great comets, can be spectacular. They can be visible in daylight. Their tails can span 30 or more degrees across the sky. They can dominate the night sky for weeks or even months. Such comets are rare, appearing perhaps once or twice per century on average. But here's an important point about comet visibility. A comet might be intrinsically very bright yet difficult to observe if it's poorly positioned from our viewing point on Earth. A comet that passes close to the Sun, as seen from Earth, will only be visible near sunrise or sunset, low on the horizon where atmospheric haze dims it. The sky must be quite dark for a comet to be easily seen, which means the comet can't be too close to the Sun in the sky. The orbit of a comet determines how it moves across our sky. As a comet approaches the Sun from the outer solar system, it appears to move against the background of stars, its position changing from night to night. The direction and speed of this apparent motion depend on the comet's orbital path and Earth's motion around the Sun. Different observers at different latitudes on Earth will see the comet at different angles and in different positions relative to the horizon. All of this matters for evaluating whether a comet could have been the Star of Bethlehem. If we hypothesize a comet as the star, we need to consider not just its existence but its orbital parameters, its brightness, its position in the sky as seen from the Middle East at various times, and whether its movement and appearance could plausibly match the biblical description. Colin Nicholl's detailed work on his proposed Christ comet takes all these factors into account. He calculates possible orbital parameters that would place the comet in the right parts of the sky at the right times to match his interpretation of the biblical and astrological symbolism. Other astronomers can check his calculations using orbital mechanics software, testing whether a comet with those parameters would behave as he describes. This represents a sophisticated application of modern astronomical knowledge to an ancient question. We can model hypothetical comets, calculate how they would appear, and see if they fit the historical and biblical constraints. We can't prove such a comet existed without finding it in ancient records, but we can at least show that such a comet is physically plausible. To understand why the Magi went to Bethlehem, we need to understand the cultural and religious context. Bethlehem was not a major city. It was a small town, perhaps home to a few hundred or at most 1,000 people. Today's visitors to Bethlehem find a city of about 25,000 people, but in the 1st century BC, it was a modest agricultural community built on terraced hillsides about 6 miles south of Jerusalem. Yet for all its small size, Bethlehem held enormous symbolic importance in Jewish tradition. It was the city of David, Israel's greatest king. The prophet Micah, writing in the 8th century BC, had prophesied that from Bethlehem would come a ruler for Israel, a prophecy that by Jesus' time was widely interpreted as referring to the Messiah, the anointed one who would restore Israel's glory. When the Magi arrived in Jerusalem and asked where the King of the Jews had been born, Herod's advisors immediately pointed to Bethlehem based on Micah's prophecy. This wasn't obscure knowledge. Any educated person familiar with Hebrew scriptures would have known this prophecy and its connection to Bethlehem. The Magi themselves were probably not Jewish, but they apparently had some knowledge of Jewish messianic expectations. How did Babylonian or Persian astrologers know to interpret a celestial sign as indicating the birth specifically of a king of the Jews? This suggests there was significant cultural and intellectual exchange between the communities. Babylon had been home to a significant Jewish population since the 6th century BC, when thousands of Jews were deported there after the Babylonian conquest of Jerusalem. Many Jews remained in Babylon even after others returned to Judea. By the time of Jesus' birth, there was a well-established Jewish community in Mesopotamia, and Jewish religious and intellectual life flourished there. It's entirely plausible that Magi in Babylon would have had contact with Jewish scholars and would have learned about Jewish prophecies and expectations. If they observed a celestial phenomenon that fit the criteria for announcing a messianic birth, according to both their astrological interpretive framework and Jewish prophetic tradition, the convergence would have been powerful. This cultural context helps explain why the Magi undertook their journey and why they knew to go to Judea specifically. It also helps explain why they weren't surprised by Herod's directions to search in Bethlehem. The small town's prophetic significance would have been known to anyone familiar with Jewish traditions. When we consider whether the Star of Bethlehem might have been a supernova, we need to understand what these cosmic events really are. A supernova is not merely a bright star, it's one of the most energetic events in the universe, an explosion so powerful that for a brief time, a single dying star can outshine an entire galaxy, containing hundreds of billions of stars. There are several types of supernovas, but the most relevant for our purposes are those called Type Sector-A supernovas. These occur when a massive star, perhaps 8 or more times the mass of our Sun, reaches the end of its life. For millions of years, such a star has been burning hydrogen in its core, fusing it into helium and releasing vast amounts of energy that support the star against gravitational collapse. But when the hydrogen fuel runs out, the star begins fusing helium into carbon and oxygen, then carbon into heavier elements. Each successive stage of fusion requires higher temperatures and pressures and yields less energy. Eventually, the star develops an onion-like structure with layers of progressively heavier elements, all the way up to iron in the very core. Iron is the end of the line. Fusing iron into heavier elements doesn't release energy, it consumes energy. When the iron core grows large enough, catastrophe strikes. With nothing to support it against gravity, the core collapses. In less than a second, material from the core implodes at speeds reaching a significant fraction of the speed of light. The core's density becomes so extreme that protons and electrons are crushed together, forming neutrons. This creates a neutron star, an object about as massive as the Sun but compressed into a sphere only 12 miles across. The collapse is so rapid and violent that it creates a shock wave that explodes outward through the star's outer layers, blasting them into space at tremendous velocities. This is the supernova explosion, and the energy released is almost incomprehensible. For a few weeks, this single exploding star can produce as much light as tens of billions of normal stars combined. From Earth's perspective, a supernova in our own Milky Way galaxy would appear as a brilliant new star. Historical supernovas have been bright enough to cast shadows at night and remain visible in daylight. The supernova of Thasan 6, the brightest ever reliably recorded, was described by observers as comparable to a quarter of the brightness of the Moon. The famous supernova of 1054, which created the Crab Nebula, was visible in daylight for 23 days and remained visible to the naked eye at night for 653 days. These historical supernovas were all thousands of light years away. Despite these immense distances, they appeared spectacularly bright because the intrinsic luminosity of a supernova is so enormous. If a supernova occurred in our own galaxy at a distance of, say, 2,000 or 3,000 light years, roughly the distance to some of the brightest stars we can see, it would be an unforgettable sight, dominating the night sky for months. The question for our investigation is, could such an event have occurred around the time of Jesus' birth? We know from historical records that several supernovas did occur in the centuries before and after. The 6 and 1054 events we've mentioned, plus others in 185 AD, 1181 AD, and 1572 AD, Tycho's supernova, and 1604 AD, Kepler's supernova. On average, visible supernovas in our galaxy occur perhaps once or twice per century. Modern astronomy has ways of detecting historical supernovas. When a star explodes, it leaves behind a remnant, an expanding cloud of gas and energy that continues to glow for thousands of years. These remnants can be detected with modern telescopes, even long after they've faded from naked eye visibility. By measuring how fast the remnant is expanding and calculating backward, astronomers can estimate when the original explosion occurred. Several supernova remnants in our galaxy have been dated to approximately 2,000 years ago, suggesting explosions around the time of Jesus' birth. However, the dating is not precise enough to definitively say any of these occurred exactly in 7 BC or 5 BC. Uncertainties in the measurements span decades or even centuries. Moreover, even if we identify a supernova remnant from the right time period, we need to determine how bright it would have appeared from Earth. This depends on both the intrinsic power of the explosion and its distance from us. A relatively weak supernova nearby might appear as bright as a more powerful one farther away, without knowing both factors. We can't be certain how visible an ancient supernova would have been. This is why the Chinese and Korean astronomical records are so valuable. If they recorded a new star around 5 BC, as some interpretations of their records suggest, that provides independent confirmation that something appeared in the sky, regardless of whether modern telescopes can find its remnant. However, interpreting these ancient records is challenging. The terminology isn't always clear. What ancient Chinese astronomers called a hui xing or tailed star might have been a comet rather than a nova. Without more detailed descriptions, we can't be certain. To fully appreciate the story of the Magi's visit, we need to understand the political context of Herod's kingdom. Herod the Great, as he was later called, was one of the most complex and controversial figures in ancient Jewish history. He was a client king ruling Judea under the authority of Rome, and his position was always somewhat precarious. Herod was not himself fully Jewish by ethnicity. His father was Idumean from the region south of Judea, a people who had been forcibly converted to Judaism by earlier Hasmonean rulers. This made Herod's legitimacy questionable in the eyes of many Jews, who saw him as a foreigner imposing Roman rule rather than a true Jewish king. To strengthen his position, and perhaps to demonstrate his piety, Herod undertook massive building projects, most famously the reconstruction of the Jerusalem Temple into one of the architectural wonders of the ancient world. He also built the port city of Caesarea, fortresses like Masada and Herodium, and improved infrastructure throughout his kingdom. These projects required enormous resources and made Herod's reign notable for both its splendour and its heavy taxation. But Herod was also notorious for his cruelty and paranoia. As he aged, he became increasingly suspicious of plots against him. He executed several of his own sons on suspicion of treason. He executed his favourite wife, Mariamne, and her mother. Augustus Caesar supposedly joked that it was safer to be Herod's pig than his son, a pun that works in Greek where the words for pig and son are similar. This was the man to whom the Magi came asking about a newborn king of the Jews. We can imagine Herod's reaction. He was always alert to potential threats to his throne. Here were foreign astrologers claiming that celestial signs announced the birth of a new king in his territory. This would have immediately aroused his suspicions. Herod's response, as described in Matthew's Gospel, fits perfectly with what we know of his character from other historical sources. He inquired carefully about the timing of the star's appearance. He consulted his own advisors about where the prophesied Messiah was supposed to be born. He directed the Magi to search for the child and report back, ostensibly so he could worship the child, but actually, as subsequent events revealed, so he could eliminate this potential rival. When the Magi didn't return, warned in a dream not to report back to Herod, his response was characteristically brutal. He ordered the massacre of all male children in Bethlehem 2 years old and under. This act, known as the Massacre of the Innocents, is recorded only in Matthew's Gospel and not in other historical sources, which has led some scholars to question whether it actually occurred. However, the absence of external documentation isn't necessarily surprising. Bethlehem was a small town. The number of infant boys killed in such a small population might have been relatively few, perhaps a dozen or 2 dozen. In the context of Herod's other acts of violence, which included executing political opponents, family members, and anyone else he perceived as a threat, the death of a few dozen infants in an obscure town might not have been considered noteworthy enough to record in the major historical accounts. The story of Herod and the Magi illustrates the political tensions and dangers of the period. The Magi's innocent question about where they could find the newborn king of the Jews set in motion a chain of events that reflected the ruthless political calculations of a paranoid tyrant willing to kill any potential rival, even an infant. This political context adds human drama to the astronomical mystery of the star. The search for the Star of Bethlehem continues to generate scholarly debate and occasional controversy. Different researchers, coming from different backgrounds and with different methodological approaches, sometimes clash over both evidence and interpretation. One ongoing debate concerns the proper relationship between faith and science in investigating the Star of Bethlehem. Some scholars argue that attempting to find a natural explanation for the star is misguided, because it was intended as a miraculous sign beyond natural law. Others contend that God often works through natural means, and that finding a natural explanation doesn't diminish the theological significance of the event. This debate plays out in subtle ways in how different theories are evaluated. A researcher who believes the star must have been miraculous might be more willing to accept an explanation that requires unusual or even impossible astronomical events. A researcher committed to finding a natural explanation might be more willing to reinterpret the biblical text to fit known astronomical phenomena. There are also debates about methodology. Should we prioritize fitting the biblical text as literally as possible, even if that makes it harder to find a plausible astronomical event? Or should we be willing to interpret the text flexibly to accommodate known astronomical phenomena? Different scholars make different choices, leading to different conclusions. The role of ancient astrology in these investigations has been particularly contentious. Some astronomers and biblical scholars are uncomfortable with taking ancient astrology seriously, viewing it as superstition incompatible with both modern science and rational faith. Michael Molnar's work, which takes ancient astrological symbolism as central to understanding what the Magi would have considered significant, has been criticised by some on these grounds. However, other scholars argue that understanding how ancient peoples actually thought, even if their beliefs seem strange to us, is essential for historical investigation. If we want to know what the Magi saw and why they thought it important, we need to understand their worldview, which included sophisticated astrological interpretation as a legitimate form of knowledge. There are also nationalistic and religious dimensions to some debates. Researchers from different religious traditions sometimes have different investments in particular theories. Some Western scholars have been accused of ignoring or dismissing Chinese astronomical records because of cultural biases. These are sensitive issues that affect how evidence is evaluated and theories are received. Perhaps most fundamentally, there's disagreement about what would constitute a satisfactory solution to the mystery. For some, only an explanation that accounts for every detail of the biblical text while also being verified by independent historical records would be acceptable. For others, a general plausibility argument showing how a certain type of astronomical event could fit the broad outlines of the story is sufficient. These ongoing debates reflect the interdisciplinary nature of the question. Astronomers, historians, theologians, archaeologists, and others bring different expertise and different standards of evidence. What one discipline finds compelling, another might find insufficient. Bridging these different approaches and creating a consensus has proven challenging. Yet despite these disagreements, or perhaps because of them, the search for the Star of Bethlehem remains vibrant. New researchers continue to bring fresh perspectives. New technologies enable new types of investigation. Ancient texts previously unstudied or untranslated gradually yield their secrets. The mystery endures, but our understanding grows deeper and more nuanced with each generation of inquiry. Beyond the astronomical and historical investigations, the Star of Bethlehem has had an enormous impact on art, literature, and culture. From medieval illuminated manuscripts to modern Christmas cards, from Renaissance paintings to contemporary film, the image of the star over Bethlehem has been depicted countless times, each artist bringing their own interpretation. In early Christian art, particularly in the catacombs of Rome, the star is often depicted simply, perhaps as a bright point of light or a simple starburst pattern. As Christian art developed through the Middle Ages, depictions became more elaborate. The star in paintings of the Nativity or the Adoration of the Magi often appears as a brilliant celestial object, sometimes with rays extending downward, sometimes with a comet-like tail. The tradition of placing a star atop the Christmas tree, now nearly universal in Christian homes, dates to the 19th century. The star topper represents the Star of Bethlehem, reminding celebrants of the celestial sign that announced Jesus' birth. This simple decorative tradition connects modern families to an ancient story, making the star a living symbol rather than merely a historical curiosity. In music, the Star of Bethlehem appears in countless Christmas carols and hymns. We Three Kings of Orient Are speaks of Star of Wonder, Star of Light, Star with royal beauty bright. The first Noel recounts how they looked up and saw a star shining in the east beyond them far. These songs embed the star story in cultural memory, passed down through generations of singing. Literature, too, has been deeply influenced by the Star of Bethlehem story. From medieval mystery plays that dramatise the visit of the Magi to modern novels that reimagine the events from various perspectives, the star serves as a powerful symbol of divine guidance, cosmic significance, and the intersection of heaven and earth. The star has also inspired philosophical and theological reflection. The idea that God might announce a pivotal moment in human history through a celestial sign speaks to themes of divine providence, the relationship between the natural and supernatural, and the question of how God communicates with humanity. These themes resonate across different religious and philosophical traditions. In popular culture, the Star of Bethlehem has become almost shorthand for any kind of guiding light or providential sign. We speak of following our star, meaning pursuing our destiny or true calling. The metaphor has become so embedded in language that many people using it might not consciously connect it to the original biblical story. This cultural legacy means the Star of Bethlehem is more than just a puzzle for astronomers and historians. It's a story that has shaped Western culture in profound ways, influencing how we think about signs and meaning, guidance and purpose, the heavens and their significance for earthly life. Understanding what the star really was, or might have been, enriches but doesn't exhaust the significance of the story.